Yeah, so this is basically just a sort of a discussion around modern applications or basically some of the concepts and architectures around it. And you also sort of a discussion around why you should be interested in adopting a cloud strategy or to look at modernizing applications. And I this came about because one of my clients asked me, well, what experience do I have in AWS? And I said, well, I don't really have much. I know Azure and I know a lot of the cloud services that Azure has, but I didn't know much about AWS. And I like to think of myself as a jack of few trades and a master of none. So I sort of went down this path to try and get as much information around AWS as I could, and sort of, up to my eyeballs in documents and videos. And I went to 2 or 3 conferences, online, luckily at that point in time, and just became a bit overwhelming. And AWS and their TLAs, oh my word, they've got TLAs like you wouldn't believe it. So I decided to sort of take a step back.
Sorry,
Yeah.
TLA is a 3-letter acronym, is that right?
That's it, yes,
okay.
Exactly. Don't worry, I'll try try very hard to elaborate on acronyms, but TLAs, 3-letter acronyms. And I sort of decided to take a sample application and broke it up, mapped it out across sort of services that that you commonly come across, and map that, services that you'd use in Azure, and sort of see what the corresponding AWS version of it would be. So this is very much sort of a discussion between Azure and AWS within the breaking up of a monolithic application. It was an interesting journey for myself, and this is sort of a summary of a few weeks of my life. And I'll take it a bit further, maybe talk about non-cloud specific tools and technologies, but we'll see about that. And as Alex said, my name is Niel Zeeman. Technically, my wife likes to call me a DevOps solution architect, but I run my own business doing consulting on DevOps. I do also consulting on dev practices, architectures, and I keep myself busy playing with new and interesting technologies in the IoT, AL, ML type space as well. So to start off with, we've got a very classic sort of a commerce type site. It's a bunch of web application, bunch of pages. It's got a catalog with some simple searches that you can perform, user profile management, custom authentication, login. So it keeps track of the usernames and passwords. So basically you can log in and see some history and previous orders and that kind of stuff. It's got a cart, and the cart has a payment process that connects to third-party payment gateways. Orders are submitted, concluded, confirmation emails are sent back and forth, passed on to the warehouse system for fulfillment and that kind of stuff. Information basically stored in a database, hosted on IIS behind a firewall, and most probably on a VM, likely under your desk, that kind of stuff. So very much sort of an old style monolithic type application. And I almost go as far as saying it might be classified as a legacy application. Now, if you ask me, why do I say that? Well, it works, for one. No big changes have been made over the last couple of years, theoretically, and it probably adheres to sort of a 2 or 3 tier, the old school architecture of like 15 odd years ago. On the flip side of it, it is probably difficult to change. JB Rainsberger from JetBrains once classified a legacy application as being profitable code that we feel afraid to change. And there's a lot of reasons why applications sort of get into the state of no one wants to touch it. Technical debt accumulates over time. Skills and knowledge gets diluted by people moving on to different projects, different teams, different companies. So you end up with something like this. As time goes on, as a technical debt sort of accrues, takes more time, more effort, and more cost to integrate new features, to change the functionality, fixing bugs or issues as well. The benefits of them sort of outweighs the problems and sorry, the issues outweighs the benefits of actually doing these kind of things. So, you know, things just don't get done, or unless at great cost. Errors are prone, you know, popping up all over the show. And it's issues to fix them, because obviously we all know that you fix an issue in one area and it sort of breaks something in a different area. And one of the reasons could be because there's very few automated tests. The concept of test-driven development, those kind of things aren't entrenched in these older applications. Slow down. The DB is not designed for these large amounts of historical data that sort of accrues over the number of years, and it's expensive to scale up, and obviously also incurs downtime if you need to shut down machines to upgrade machines. And scaling out, of course, also takes a lot of effort, and it could be expensive to provision new hardware or to boot up new VMs. Third-party integration changes, updates as time goes on, and it simply just gets too expensive. A lot of services will increase in pricing, and the services and the levels of service provided may not be you know, equatable to the cost you're paying for them, but you can't move because it's too cumbersome to update or to move to a different provider. Security, having one monolithic application basically gives you a single attack surface. So as soon as someone's into your application, basically they've got free reign to find what they want. And that we've seen recently is actually becoming quite a problem, even though it's more human error than system error. But anyway, and it's just not cool to sit with legacy old school applications. And as funny as that statement may be, it is difficult to attract new devs or new people with old technology. I mean, those are the facts. So those are some of the problems that are faced with old applications, with old legacy monolithic applications. And with this attempt to map out a journey of modernization, so what does a modern application look like, you know? And there's a lot of buzzwords flying around, you know, but I believe that the foundations of modern applications should at least have some concepts such as microservices. Now, these are small domains which are manageable. You make a change in one small service, deploy it with relative ease, and it actually has little impact to the system as a whole. And people, just to draw the line there, if you have to deploy the entire system to make a fix in one area or an update, that is not adhering to microservices practices. Containers obviously a nice way to enforce these microservices boundaries. It provides a mechanism to transport the service application or process in sort of a non-mutable fashion, and it makes it easy to test it as a unit. And obviously having multiple containers also reduces the attack surfaces. Of course, cloud, the fact that managing our own data centers is expensive, outdated, and prone to capacity problems. And it just doesn't give us the agility to test hypotheses, to have access to the required resources when and how we need it, and the ability to scale on demand or consume those services that last week we didn't think we needed. Okay, at the flick of a button, we can turn them on. And all of this, actually, why would I care about infrastructure? You know, I want to abstract those things away. This whole idea of serverless actually fits in very nicely into a microservices concept. Little pieces of functionality that builds a whole. It's basically available individually and can scale at a drop of a coin. Then the machine learning or artificial intelligence, it gives us capability to make informed decision at unimaginable scale and speed. It's, data. Everything is about data. That old adage, if you don't know what the product is, then it's probably you and or your data. Having all of this data doesn't mean anything if you can't actually do something with it. So we can use data to train models, which basically allows us to quickly and efficiently comb through large amounts of data and find stuff from potentially fraudulent transactions to fake news, user buying patterns, diseased crops on farms, and or simply just respond to the majority of repetitive customer queries so that you can actually focus on what really matters. We should be making the bulk of all of this mundane stuff and services someone else's problem. Focus on the things that makes us or our company stand out. I mean, why does a call center need to know how to wire up a PABX, or why does a financial house need to know how to spin up a Kubernetes cluster or OpenShift on a server in a data center? They just don't. All of these concepts sort of feed into the ability to allow us to focus on what differentiates us from our competitors. And it, gives us the ability to make changes quickly and efficiently. We can and should, of course, automate as much as possible, get those critical bug fixes out in a matter of hours as opposed to months or weeks, so that we can get that new feature out that will make us stand out even further, in a fraction of the time that it would have normally. And after all, you said and done, all these sort of concepts taken as a whole, if you aren't doing it, there's a good chance your competitor is, right? Well, enough about that. So I'm going to talk about how we look at this application, sort of break it down into small manageable chunks. And I'm going to sort of describe the technologies that I've come across and what makes sense to me, at least, to incorporate and take a lot of this stuff away from us so that we can just leverage these services and, once again, focus on what we need to focus. I'm going to focus in on the application itself, and I actually want to start by drawing out the contextual boundaries. Now, Eric Evans, quite a while back, wrote a book called Domain-Driven Design, and more importantly, he talks about the bounded contexts within applications, and this feeds very nicely into a modern sort of microservices mindset. And at this stage, we could containerize these services, slap it into a Kubernetes cluster and call it a day, right? Well, I'm more interested in reducing the amount of work and leveraging what I can from elsewhere to let me, once again, focus on the stuff that I need to focus on. So, first problem, authentication. It is a pain at the best of times, username, password management, then you've got encryption, you've got multi-factor authentication, etc., etc., etc. It's just a pain. And I know I get annoyed when I need to go to sites and they inevitably ask you to log in and create a new login and password. It's just a pain. So everyone uses social credentials, and I want to be able to do that. But I also want to be able to create application password if my users or customers want to. Fortunately, we've got Azure B2C services and AWS Cognito services. So we can leverage these services to give us all that functionality and integrate it seamlessly into our application without having to worry about doing it ourselves. So we basically hand over the safety and security from the authentication point of view to another service and integrate it into what we need. So we can still store information around it, particularly around authorization, but the authentication can get done somewhere else. Next up, we'll look at glossies or static pages, and these are just overview information, contacts, that kind of stuff. It's currently stored as part of the web application, but we can separate them. because we can. And a cheap and easy way of hosting static pages, even single page applications or spas, would be something like blob storage in Azure or S3 storage in AWS. It's a quick, easy, cheap way of hosting static pages, hosting content, and I'll go into that a bit later as well. Now, we could, of course, also go and host this as a web app or Elastic Beanstalk service, but I'm sort of just delving into the different usage scenarios, so we'll look at those a bit later. For the timing, this should suffice. Then next up would be the catalog, and this just shows a list of items that would be for sale. It's got basic search capabilities, such as, you know, search where description like type of things, and then we can take these items that's being returned, add them into a cart. And I'm going to sort of complicate things a bit here, but I think the end result is going to be a bit, well, quite a bit better. Firstly, as I mentioned earlier, we'll host the application, or the catalog in this case, in a service like the AWS Elastic Beanstalk or Azure App Services. And both of these actually has the ability to run containers or images. And we can take the application, deploy it into an image, and deploy it into these web services. So that gives us future, you know, sort of future proofs if we want to move that way. Then the information that is hosted in these catalogs, I want a read optimized store. And for this, I'm going to sort of use a good old fashioned relational database, and AWS RDS and as that, it's relational databases that we can leverage. The images, binary files, you know, PDFs, that kind of stuff, it'll work out way too expensive to take those and dump them into a database. So once again, we'll leverage a much cheaper store in terms of our S3 or blob storage instances. I can just dump them in there, reference them out of there, done. Then, because SQL databases are quite expensive to operate and manage, you want to optimize the access, optimize the queries that you're using. You know, you don't want to hit the database a million times if you don't need to. And for that, we'll cache as much as possible. And we can use something like your Azure Redis Cache or AWS Elastic Cache to cache queries, results, that kind of stuff from our catalog store. Then I want to go ahead and improve the search capability. I want better performance and predictive searching. You know, like Google, when you start typing, it actually gives you sort of the potential ends of the sentences, and also potentially make it multilingual. And the importance of search, I can stress here. You know, when I did this talk earlier, it was after a week or so of looking for something very specific, and I went to Takealot and Loot. Now, do yourself a favor and just go and exercise the search capability between those and sort of see what the difference is between a good experience and not so good experience. And I won't tell you which one's better or worse, and you can go figure that one out for yourself. So we've got a few options here. We've got Elasticsearch or Cloud Search from AWS. Elasticsearch is obviously based off of Elasticsearch. Now, it's fairly manual to set up and configure, and it needs management in the AWS context. So I'll just stick to something simple like Cloud Search. You know, I'm lazy, so something quick and easy would do for me. And Azure just has the cognitive search, which gives us all of those, you know, performant, predictive search, multilingual capabilities. And then we understand that a stable application is one that has an absence of errors, and by the time that a service actually becomes unstable or issues start becoming apparent, there's actually been a number of things that has already started failing. So we want to proactively go and monitor what is going on in these things. Things like, how is the service being used? Where are the bottlenecks? How the consumption is growing? Where are the issues coming from? When are the issues coming from? In what scenarios these issues or failures are originating? And decent monitoring in both services comes in the form of AWS CloudWatch and Azure Application Insights. It has quite detailed monitoring capability and can even notify us when errors or issues start occurring and when we reach usage limits and all those kind of things. So we can use that. Okay, so now for the cart and some of the aspects around that. I'm going to start out with kind of the same approach as we would in the catalog, but I'm going to mix it up a bit. Instead of your relational databases, I'll use a NoSQL database. Now, there's a lot of options in the NoSQL or document DB space, but I'll stick to my script here. And talk about AWS, which has two options. It's got Document DB and Dynamo DB. And it really becomes a choice of what you're wanting to use, your business case, your scenario. So it's up to you to go and spike some POCs to make sure that it's going to fulfill the needs that you have. I'll use DynamoDB here because, well, it's been around longer and simply just has a better support for different languages. Document DB is still getting there. Azure has the same issue. It's got table storage, which is sort of the poor person's version of a document DB, and then it's got Cosmos DB. Cosmos DB, much better. Cosmos DB, much cooler features, and also much bigger support for different service systems in different languages. So we've got an option of Dynamo and Cosmos here. Then on completion of a order, so when someone's taken the order, I want an instruction to go to the warehouse, but I want it decoupled from the system, from our cart at least. It must be almost like a send and forget type of instruction, and something else will take care of it. Okay, so here we've got couple of options. Once again, we've got on your AWS side SQS or simple queue services. I told you there's TLAs till they blew in the face. SQS, SNS, simple notification services. For AWS, in Azure, we've got Service Bus, Event Grid, we've got queue storage, and each one of these services sort of bring more and more capability. So you've got stuff like pub sub, and you've got routing, and you've got guaranteed delivery and all that kind of stuff. So this is not even talking about other systems like RabbitMQ or Kafka and those kind of things. So on our cloud journey, I'm just going to stick to a simple queued item. It's going to be picked up by a different service and A for away. So I'm going to use your SQS simple queue service or the Azure queue storage in this scenario. Now, the cart integrates into the payment process or payment gateway, and there are a number of ways to do this, and this can be fairly brittle and fairly, prone to change, prone to issues, and we want to abstract it sort of into a small function that we can easily scale when we start processing millions and millions of payments. So we'll use AWS Lambda or the Azure function that will basically give us the capabilities, sort of single responsibility type approach, small specific routine that can get updated with relative ease. Then after the checkout has been completed, we need to instruct the warehouse that they need to pick the item, ship it via the courier, and give us feedback, as the process goes on. As I've mentioned in the cart process, the kickoff point here would be a queued item. So from there, we're basically looking at sort of a classic workflow scenario. So we need to notify the user that it's now getting processed. We need to send a request to the warehouse, get feedback from the warehouse when they ship it, inform the user that the courier service or the courier details, finally get feedback when it's ultimately delivered. So I'm going to sort of bundle this into a single sort of area and just highlight some aspects. And as I've said, mostly want a sequential workflow type of process to handle this. We will look at something like AWS SWF, which ironically stands for Simple Workflow Service, or Azure Logic Apps. Let me just get there. So these are the workflow systems that is in both providers. They provide good connectivity to third-party apps and services. And if there aren't any connectors, you can just create a little serverless function or write your own. And speaking of that, we will obviously need to interact or connect with our warehouse systems. So we write a little function to connect and basically bring the warehouse system into our workflow as part of our workflow, sort of as an anti-corruption layer, if you like. We also, as part of this system, need to send out communication. Now, the AWS actually has a simple notification service, SMS, that gives you the ability to send emails or SMSs, and you can use that, integrate with that. Azure doesn't have anything out of the box, but they do have stuff like SendGrid that you can spin up and use to do pretty much the same. Then, let me just, the notification obviously can get used sort of across multiple services. So I'm going to bring it in here as a shared service so that we can share it and use it throughout the system. Next up would be all that data that we've accumulated, the historical data that's slowing down the system. We've consumed it, we've trained our models. Now we want to stash it somewhere cheaply, safely for potentially future use, where we want to be able to get at it, but not in a real-time type of scenario. And there's a couple of options on both providers. Basically, it's just different tiers of storage, actually. Azure, we've got cool or archive tiers in your blob storage that you can dump stuff into. And AWS, we've got the S3IA or infrequent access and Glacier classes of storage. It's a lot cheaper to dump your data in a service like that than to keep it in a database in a hosted environment. And talking about the database at this stage, it's pretty much old news. So a lot of the data aspects has been absorbed by these services in one form or the other. So we can make it a lot less prominent. Now, at this point in time, I need to take sort of a broader look and expand the topology and see how we can bring all of these services and aspects together as a single cohesive application. And for that, firstly, I'm going to start by putting an API gateway in front of these services. AWS has API gateway and Azure has API management. They provide a bunch of services and capabilities, a lot of around security, which is a good thing, but also they provide the capability of routing and versioning. Now, this gives us the ability to actually run multiple versions of the API at the same time. And we can then deploy at any time and simply start routing the traffic between one service or the other. So we're running two services at the same time, merely manipulating where the traffic flows. And this gives us a very good or an agile capability in deploying, because we can deploy whenever we want to and just slowly move the traffic over. And of course, if the new service goes belly up, we can just roll back to the old service. We can also, at this stage, get rid of IIS because, well, all these services are basically web accessible by nature. We'll slap on a global access point in form of a AWS Global Accelerator or Azure Front Door. And once again, a lot of capability that these services have in terms of security, giving you a regional point of access, so point of presence. So it actually has points in your different regions to get onto their backbone network, traffic routing, and also some caching. Now, I'm still going to add a CDN, content delivery network. And most people will actually point you to something like Cloudflare as opposed to one of the Azure or the AWS services. But AWS has CloudFront and Azure has Azure CDN. So I'm not going to brand that, but I am going to include it, you know, just to make the diagram look a bit more cluttered than it is. And speaking of the clutter, also all my well-crafted and complex looking animations, I just want to almost summarize the topology a bit. And each of our mini services will leverage sort of what it needs to perform as functions, performance jobs. And it shouldn't be complicated, as all the previous slides might portray. As long as the interfaces are defined and maintained, you should be able to swap services at each point for something that is a better fit for your business, more functional, might have more features or a specific feature you're looking for, or even from a cost point of view, you can use cheaper services at certain areas. Now, I can't not talk about DevOps and automation because that's, well, quite a big chunk of my bread and butter. And we want to take these services, this environment, basically manage it from development all the way into production and leverage it to give us, you know, the ability to quickly and easily deploy all our fancy new features or bug fixes or issues right from, you know, the environments all the way into production. Now, both AWS and Microsoft have sort of their own development management platforms. AWS Code Services has code commit, build, code pipelines, code deploy, and the tagline, if you go onto this site, is host code, build, test, and deploy your applications to AWS. Okay. Azure or Microsoft has Azure DevOps, which runs in Azure, but it's actually not part of the Azure environment. They have boards, repos, and pipelines, and their tagline is build, test, and deploy with CI/CD that works with any language, platform, and cloud. Now, I'm biased, so I'll leave those taglines to resonate with you, and you can make up your own mind as to how these things are progressing. Anyway, leveraging these services, we've got the platform to manage our development environments or our developer environments. Now, leveraging them to actually take or manage the environments or the configurations in our cloud environments, there's different ways of doing this and different ways of executing instructions to manage the resources in our environments. So I'm sort of talking about infrastructure as code, sort of a mindset. And a few clicks behind, both Azure and AWS has a pretty good CLI, so we can run commands to create a resource or manage or update resources. And we can run multiple commands to set up sort of bigger environments. But that also just goes up to a certain point and it becomes a bit more difficult, shall I say that. So to build on top of that, both of them have sort of a templating environment or a templating type approach in terms of CloudFormation on AWS and ARM templates in Azure. This describes the entire resource structure as a JSON or YAML or textish type document. And basically, we can take that description and tell the provider, apply, and it will spin up, create, configure, reconfigure resources based on this definition. So both of them have them. Now, the next becomes a bit interesting because AWS also has this thing called CDK, or Cloud Development Kit. Basically takes a templating approach a step further, and you can go and describe your environments in code. So C#, Node, Java, JavaScript. You actually develop the resources using a DSL, or domain-specific language, and then you can compile, execute, and it generates those templates that then you can apply into AWS. There's some third-party tool called Pulumi, which you can actually target Azure, AWS, even Google. But the CDK was pretty nice from a first-party point of view. And actually, in the last couple of weeks, there's about I came across another 2, Bicep DSL, which is another language for Azure, and also Farmer, which is an open source project for specifically Azure, but third-party tools. And so, talking about that, so I've stepped through taking a monolith and sort of dissecting it into small services, went over the services that worked. I was very selective in what I was using and what the ones were that I evaluated. So a large number of services keep popping up, and both providers on a fairly regular basis, and some of these might not even be the correct fit for certain scenarios. But my intent out of this was to give me some coverage around the basics, and for you to sort of think about the possibilities of reducing your workload, code or infrastructure dependencies. And that brings me to the end. So last statement is, if this was interesting, please let me know. If you are interested in more sessions like this, also let me know, or delving deeper into some aspects, specifics like development technologies around this, let me know. I'm always looking for an interesting next topic. And with that, I think Alex is prompting me that my time is up, and I will hand it over to Michael.